Good morning, guys, and welcome to this video. If you've made it this far, I'm really glad that you have. In this video, we're really going to talk about classes and objects. I remember that I said our next video is going to be on web development, but it's really important that we understand what classes and objects are before we proceed, right? So, I have a picture on my screen of a game, and why do I have a game here? I feel like the best context to explain what objects are via video games. So video game programmers literally think objects and classes. And let's look at this video here. This is PUBG Mobile. It's a very popular game now. This is probably not a very good example, but let's imagine for a second that the two people on screen here are holding guns, right? So this guy is holding a gun and this guy is holding a gun. Now, the way games work is when you shoot a person, in a lot of games, the person doesn't die instantly. The person has a lifeline that reduces with each bullet he takes. Now, how does that work in a game exactly? How do you implement that? I'll tell you how for free. So here, this is an object. So this is a person object inside of our game. Our game recognizes the character on the left as a person object and the character on the right as a person object too. So we have two objects. So what are objects? Objects are those things that can interact in our program, right? Or that can interact with our environment. It's just like in the real world. In the real world today, I can interact with you. I can talk to you. I have actions. I have feelings. I have emotions, and then I have attributes. I have black eyes. I have long limbs and all of that. So I'm an object with all these attributes. The same thing in a game. This is an object. This person on the left is an object, and the person on the right is an object. Now, the gun that they hold is an object too. The bullet coming out of that gun is an object. How do we know when someone has been shot in a video game? Every object has an X and Y coordinate in a game, right? It's the same way wherever I am in the world. I have my latitude, my longitude, and probably my altitude to describe which point I'm standing at that point. So in the same way, in a game, every object has an X and Y position. Now, how do I know someone has been shot? I know someone has been shot because I am constantly checking if a bullet is in the same XY position as that object at any point in time. So if I detect that a bullet position has changed from probably a gun's XY coordinate to the same XY coordinates being occupied by a person object, I know that this person has come in contact with a bullet, and then I go to the person's life and I remove probably 1 bar or 2 bars. Now I'm going to bring it, this is probably not the best example. I'm going to bring it to the real life, right? So if someone takes a machete to my hand, what happens in the real life is because that machete has gone through the space that my hand used to be at, I lose an arm. It's should I say it's basic physics, but that's the way it happens in games too. So what we really have in games are objects interacting with each other, right? And that's the simple thing about objects. When we say classes and objects, that is for objects. That objects are really just things that interact with each other, and we build up objects to help us abstract certain kind of thinking. So we have different types of objects. We have a gun object in our game. We have a person object. We have an environment object. For example, this place they're fighting in now, it looks kind of like a stadium. So this is an environment object. You might have another environment object which can be a garage. So if you decide that you want to fight in a garage, you're going to be put in a garage environment, which is an object too. And that's really what objects are. They simply allow us to build up our programs with different kinds of objects. Now, that is one example that I like to use. I'm going to proceed to the next example. What are classes then? If objects are things we use in our code, what are classes? And to explain what classes are, I'm going to like to start from talking about baking, right? So we need to bake a cake or something for a wedding. And apart from the dough, so we have to mix our dough really. So that's flour, eggs, milk, butter, margarine instead. So we need to make a cake. So we've made our dough. What happens next? What happens next is we put our cake in a pan. We'll put our dough in a pan, put it in an oven, and out comes a cake. So let's look for baking pan. And I'll just go to the images. And I'll pick this one. So let's say I buy this baking pan. Okay, let's say I buy this baking pan, right? I have just this baking pan and I want to make 5 cakes. What am I going to do? I'm going to make enough dough to make 5 cakes. And then I'm going to put my dough in this baking pan. I'm going to make a cake out of it. And when the first one is ready, I'm going to take the same, what's it called? I'm going to take the same pan, put more dough in it, make another cake. How many cakes do I have now? I have 2 big cakes. What do I do next? Remember I need 5 cakes. I'm going to take some more dough. I'm going to put it in this baking pan and out comes another cake. That's 3 cakes. I'm going to do this 2 more times. That's 5 cakes. Now what I want you to understand here is that out of this one pan, I have made 5 cakes. Now, these 5 cakes are independent of each other as long as we're concerned. They're not related to each other in any way. If I cut one cake, it doesn't mean the other cakes are going to get cut or they're going to feel cut. It doesn't mean I have to send these cakes to the same person. These cakes can have very different lives. One of them can be consumed today, another one would stay in the fridge. But the fundamental thing to understand here is that they all came from the same baking pan. Now think of those cakes as objects and think of this baking pan as a class. So then what is a class? A class defines how an object is going to be when that object is created. So a class is called an object definition. It tells you what an object is going to be like when that object is created. And then an object is created from a class. So now we have our one baking pan, which is a class that specifies the shape a cake is going to come out in. And then with that one baking pan, we can make several cakes. Before we even go into code, I want you to understand that basic, right? That the pan is your class and your cakes are your objects. What is the relationship? The pan defines how the cake is going to be. And one fundamental thing you should know here is that one class can be used to create several objects. So all you have to do is create what's it called, a class, and out of that class you can just keep churning out objects. And now taking it back to our game example, when I'm programming a game, all I have to do is define a person class. I'll define a person class and say, oh, a person is going to have a hand, a person is going to have 2 hands, a person is going to have 2 legs, a person is going to have a head, eyes, a person can move, a person can hear. And then after defining the class, I can then stop. Each time I need a new character, I can just go to my class and say, hey class, give me a new person. I need a new person. And it just keeps giving me people to use in my game. Now, these people are independent of each other. Their game lives can differ, but at the end of the day, they come from the same class. And that really is the distinction between classes and objects. So I hope that's clear. If it isn't, you can drop me a message. I'm usually busy nowadays, but I'll try to attend to them. So that said, let us look at some code. So I have my terminal open here. I try to make it bigger, so hopefully you guys can see this clear enough. Just make it a little bigger. So I will go to, I usually like to put my project in one directory, so I'll go to where I put my project. And then I'll just say, as usual, .NET new create a project, classes and objects, .NET new console, and classes and objects, and I'll just hit enter and let it create this project for me. Okay, created the project successfully. It's restoring NuGet packages now. Alright, that's great. So I'm going to say code. I'm going to first go to the folder, cd classes and objects, and then I'm going to say code and dot to open it in Visual Studio Code. Alright, we have it open in Visual Studio Code. Now I'm just going to open program.cs. I'll take out this, so we don't need it right now. And so far, all the work we've been doing, right, we've been doing it in the same file. We've been only using one file, but the truth is, it becomes unmanageable. So for a very complex system or a very complex game, you really can just put all of your code inside of one file. And this is the first time we're going to use a different file. So we're going to create a class, or we're going to create a number of classes now. And what we're going to do, first of all, I'll save this. And I'll just come over here and remember to click out here so you don't put the class in any folder. And then I'll click on new file. So this is a new file icon. I'll click on new file and I'll name it what should I name this class? Let's name this class student.cs. Should we use this example? Okay, let's call this class student.cs, right? And then I'm going to come here. I need some of these things in my student class. So I need the namespace. I'm just going to copy all of this because I need them to be in the same namespace. You don't have to understand what that means now, but as we continue, all will become clear. So namespace, classes and objects. And how do you create a class? So first of all, I'm putting my class in a namespace, which is the same name with my project. And then the way to create a class is to use a class keyword. In fact, we've been working with a special type of class called the program class. So I'm just going to come back here, and then I'm going to say class student. Now remember, what are we doing here? I'm going to make this a public class. Remember what we're doing here. We're defining what a student is going to be like, right, when we actually create the student. So what things should a student have? So public string name. A student should have a name. Okay, set public string course. Let's see the major, so what they're studying. And we use courses in Nigeria, so let's see public string course get set public string GPA or CGPA. Let's say we want to be able to know every student has a CGPA. Get set. What else do the students have? Public string level. So we're modeling this class after a university student, right? Or I'm making mistakes here. So they should be course. The CGPA should be a double because it's a decimal, and the level should be an integer, because it can be either you're in 100 level or you're 200 level or you're 300 level, or so we have all of that, and we have our student class. Wondering if there's any other thing I can add to our student class now, but let's keep it simple for now. And we have a student class. What we can then do is when we come to our code, we can create students. So the way to use our student class is to first of all, let's create a new student. I'll say var, or I'll use the name of the class student, S1 equals new student, right? So this creates a student object for me. S1 is a student. Student is the class. This is the object, and this is the class. So this class is our baking pan. It defines all the things the student should have. And I just created a student here. So I'm going to do something here. I'm going to say console dot write line f1 dot name. So I want to print the student's name, right? So I just created an object which is an instance of the student class. It's like I just made a cake out of a baking pan. My student class is a baking pan, and this variable I have here, this S1 is an actual student, and S1 has a name because all students should have a name according to our class definition. And then I'm trying to print out the name of the student here, so I'm going to just say hold on, let me try to. Okay, that's too big. I hope you can see my terminal here. I'm going to bring it up, and I'm going to say .NET run. And we can see that nothing is printed out. This has finished running and nothing was printed out. And the reason nothing was printed out is we've not given a name to the student. All we've done is we've created a student, but we've not named the student. And like I said, objects have properties, right? For example, I am an object. I have a voice. I have limbs. I have a name. So if someone wants to refer to me, imagine I was born and I was never named. That way, I don't have a name. So how do people refer to me? So because we've created an object, let's go ahead and say s1.name equals Vincent Warner. And I just created a student object, and I gave that student object the name Vincent Warner. I'm going to create another one, S2. I'll say student S2 equals new student, right? And I'm going to say S2 name equals Richard Warner, right? So now I have two objects. They're coming from the same class, but they're independent entities, right? They're very different from, they're both students, but they can have their own properties separate of each other. So we see that from this one student class, we've made two students, right? And this is the kind of thing you're going to do when you actually start writing applications. Early on in my career, I wrote a school management system, and I just had a student class, and my student class had your level, your course, or your scores for different courses, and it was just easy to manipulate objects like that. I can call a student object, check okay which student object has the highest CGPA or which of them, and display this result. So this time I'm going to write console.writeLine s1.name and then console.writeLine s2.name, right? And I have that too, right? I can now bring up my terminal again and say .NET run. And this time I have two names. I have two students, Vincent Warner and Richard Warner. Let's go ahead and fill in some, let's create some more students. Let's just give this a CGPA. So s1.cgpa, let's say my CGPA is 3.5, and let's say my brother's CGPA, Richard is actually my brother, s2.cgpa, let's say his CGPA is 4.9, right? And then I can come here and say if f1 dot CGPA is less if f1 dot CGPA is less than s2 dot CGPA, I want to display s2 dot I want to display console the right line s2 dot name clause has a higher CGPA. Let's say has the highest CGPA, and we're just going to end this statement. Then the else, I'm just going to copy this and change a couple of things. Else s1.name. So what I'm doing here really is I'm checking, okay, is Vincent's CGPA higher than Richard's CGPA? Is it lower than Richard's CGPA? If my CGPA is lower than Richard's CGPA, then I want to just print that Richard has the highest CGPA. If not, I'm going to print that I have the highest CGPA. Let us run this and see. Once again, .NET run, and we first have the names printed, and it says Richard Owner has high CGPA. And these are some examples of what you can do with objects. They're really powerful. They're really powerful structures, right? Great. Let's look at some other things. So let's look at other kinds of objects. Let's say you're writing, right now we're using people, but let's say you're writing a maths application, for example, and you need to talk about shapes. How do you deal with that? Let's say you need shapes in your application for whatever reason, and your shapes need to have a direction or any of that, right? I'm just going to take out everything I've written so far. I'm going to leave our student class. So I'm going to come here and create a different class. I'm going to create a new file and say this class is going to be a rectangle.cs. So remember our namespace class is an object. Then I'll say public class rectangle. So there I have our class. And what things does a rectangle have? A rectangle has a height and a width. There's a public double height get and set, then public double width get set. So I have a height and width. What other properties does a rectangle have? Color. So I'm going to say public string. Let's say the color is the string for now. Color get set. Let's see which other properties does a rectangle have. Okay, so that's it. We have, okay, let's put the position of our rectangle. We'll see public x position get set. Let's say public double x position, so the x position of this rectangle, and then lastly public double y position get set. Okay, so we have a rectangle here. We have the height, we have the width, we have the color, and all of that. So we have a rectangle class. Now let us create some rectangles out of this class, right? I'm going to come back to my program and I'll say rectangle first rectangle equal new rectangle. Now I want you to think of this first rectangle that we created here, the variable. It's just like saying var string equals hello world. Now this in the same way that string, let's say string new string equals hello world. The same way we think of new string as a variable of type string, that is exactly the same way first rectangle is a variable of type rectangle, right? So we just created our first rectangle. Let's give our rectangle some properties. So I think I'm just going to make this shorter, so it's easy to type. I'll call it R1. So we come down here and we say R1 the height equals, it's 100 centimeters high. The width, let's say 100. I want dot y position equal, let's say it's at 0. I1 dot y position, let's say it's at 0 too, so let's say it's at the very edge of our axis. So if we had a let's see if I can find an image of a graph. Damn, I couldn't spell graph for a second there. So this is a graph, right? And this is a 0 position. So this is 0 on the x-axis and this is 0 on the y-axis. So if we have a rectangle at position 0, 0, it's going to be right here in the middle. So 0, 0, right? So that's it. So we have R1's position is 0, its x position is 0, and its y position is 0. It means that if this was our screen, our rectangle would be right here. So that's this for this rectangle. Let's create a different rectangle. Rectangle R2. I feel like saying R2D2 here. Oh, I said it. Rectangle R2 equals new rectangle. So I have R2 dot height equals 100. R2 dot width equals, let's say the width for this one is 200, and then R1 dot x position equals, let's say this one's position is at say 5, and R2 dot y position, let's say it's 10. What else is in our class? We have the color, sorry, and let's say this rectangle is red. R1 dot color equals red, and R2 dot color equals black, because I really like black, so I have to use black here. And now we have two rectangles. By the way, let us look at where this rectangle would be on the screen. So it's a 5 on the x and 10 on the y, and so that would be somewhere here. Hold on. So 5 on the x, so 5 on the x and 10 on the y. So this rectangle, this second rectangle would be somewhere around here, higher, probably higher. So we just have it here. So we have our first rectangle here because of its x and y, and we have a different rectangle here. And if these were game objects, if these were actually people, we would see on our screen, we'll see one person here and then we'll see another person up here. It's like when you're playing Tetris, the popular block game. So let's look at Tetris. Tetris is, I think Tetris is the perfect example. I don't know why I didn't think of it earlier. So this is Tetris, and this is a rectangle. This is a rectangle. It has a height, it has a width, and it has a position because right now it's here. And then what we do in our program when it comes down is we keep checking its position. These ones have positions too, and we keep checking its positions for when it hits home. For whenever it hits the base here, we stop it, so its lifetime has ended, and if it completes any of these rows, they go away. And once its x and y position matches the x and y position for the things down here, we know that it has reached the end, so we can bring out a new rectangle. So that really is how it works. So this is the x and y position for this rectangle. So what are the kind of things we might want to do with our rectangle? The first one is we might want to check if it has hit, if its x and y coordinate has reached, if it is moving, right? If its x and y coordinate is changing. What we want to do here is we want to create something called a method. So far, we've been writing all of our code in main. Main is something called a method, but it's a very special method. The first time your project runs or your program runs, it's going to look for the main method, right? And it is going to execute the main method. This is a main method. So everything from here to here is known as a code block, and this code block is called the main method. The same way that we're creating a rectangle and we're naming it R1, in that very same way, we're creating a method and naming it main, and this method contains all of these things. Now, the good news is that we can create other methods, right? It doesn't have to be one method. All of our code does not have to be in main. As a matter of fact, we create methods to do very specialized things. Like we create a method to do a simple job, and it returns a value for us. So follow me. I'm going to create a method now. I'm going to say static bool is shape square, open and close the brackets. I'm going to write rectangle R, and then I'm going to come down here. I'm going to explain everything I'm doing here. Just stay with me. Now I'm going to say if R dot width is equals R dot height, return true, else return false. Now if you're wondering what I typed here, it's just a double equals. So because I'm using the font, when I type two equals, so with no space between them, it changes it to the double equal symbol. Now let me explain what is going on here. So first of all, I told you we're going to create a different method. So if you notice, this is a method because we have a code block here. Our method has a name. And one important thing to know is that methods reside in classes. So this is a code block for this class. And then this is a code block for this method. And this method is within the program class. Good. So this shape square, right? We're checking if the shape is square. So what this method is supposed to do is it is supposed to check if a rectangle is a square. And how do you know that a rectangle is a square? You know that a rectangle is a square if the width and the height are the same. So let's look for a square. So here we have a square. The thing about a square is that the width is always equal to the height. So if we define a rectangle here and our width is the same as our height, then that rectangle is a square. And maybe for some reason we need to keep tracks of which rectangles are squares and which ones are not squares in our program. What we would do is we would write a method, is shape square. And what we're doing here is when we create a method has some necessary things. First of all, because that method is going to do work, we need to tell our program what kind of value is this method going to return at the end of the day. So after doing all this work, what value is this method going to return to whoever asked it to do work? Right, because our method cannot just function on its own. Someone has to call our method and instruct our method to do something. Someone has to invoke our method and pass some value to the method and say, hey method, go and do this calculation and come back with a result for me. But first, we need to tell the record what kind of result to bring back. I mean, someone can just call me and say, hey Vincent, I want a website, here's some money, go make me a website. The person needs to tell me what kind of websites they want. So we need to tell our method what kind of value it's going to return. And that is what we do on this line. On this line, we're telling our method that, hey, you're going to return a boolean, which is a true or false. So whatever this method does, at the end of the day, we're going to return a result that is either a true or false. And that makes sense, because if we want to check if a shape is square, if we ask someone, hey, is this shape square, what they say is either yes, it is square, or no, it is not a square. So this tells us that our method is going to return a boolean value, a true or false. And now let us look at our main method for a minute. Our main method is returning a void. Now, what does void mean? Void means, hey, this method is going to do some work, but it is not going to return anything. It is just going to exit. And as the entry point of our application, that makes sense. When we open our application, everything in our main code runs, and when it's done running, it just exits and our program closes. We're not returning anything to anyone. So when your method does not return anything, we use the void keyword. Good. So in this case, we're returning a bool, which is a true or false, which makes sense. And then what is this here? This is, we're telling whoever is going to call our method that, look, if you want me to check that if a shape is a square, you have to give me the shape to check. I can't just manufacture a shape out of thin air and check if this shape is a square or not. So what we're doing here is we're saying, oh, when you call a shape square, pass in a rectangle, which I am actually going to check. And that is what this line here does, this bit of code here. It says, hey, I'm expecting you to give me a rectangle when you call me. I hope that is clear. Now we're just going to come into the method, and what I'm doing here is if r.width equals to r.height. So I'm simply comparing if the rectangle that is passed in width is equal to the height, then we know we have a rectangle, and then we return true. Now a return statement is used to return a value from a method. So immediately our code hits this condition and evaluates this condition, and it says, oh, okay, yes, they're actually the same. It returns true. So it tells anybody that called it that, oh yes, they actually are, this shape you passed me is a square. And then if this fails, it comes to this next statement, and else it says false, or the height and the width are not the same. So I'm sorry, this is not a rectangle, right? And that's the basics of that's really the basics of methods. You can create various kinds of methods to do a lot of things, right? There are a lot of methods available from C#. For example, I can let's just do something very quickly here. I can see console right line max dot square root 16. Let's break this down a bit more. So I'll see double SQL equals, so I'm creating a variable named, I'm creating a variable and I'm naming it SQL, and I'm setting the value to max just square root 16, and then I'm going to just console the right line the value in SQL, right? And let's just run this as usual. So .NET run, it's going to print out every other. Okay, so we have a 4 here. So SQL was 4. Let's see what's going on here exactly. So what we're doing here is I said, hey, give me the square root of 16, and we all know the square root of 16 is 4, and I just printed it out. And how did I do that? There's a class in .NET, which .NET provides to you by default, called the maths class. Right? Let's see if we can go to it. Let's go to the definition of this class. And this is a maths class, and it has a lot of properties, just like the class we created. So when you're creating classes, it's not magic, right? The entire .NET is actually a collection of classes that have different abilities. For example, today we have created a method that checks if a shape is a square. We can take this method and give it to someone else to use to check if a method is a square in their own program. In the same way, the engineers at Microsoft have created this maths class that has a lot of important methods that we use in our day-to-day work. So for example, I need to check the square root of a number, and all I have to do, let's see, Ctrl F SQLite, all I have to do is to call this method. This method takes a double or an integer, takes a double and an integer, and then it returns the square root of the number. And that is all I'm doing here. I am calling the method, I am using the method here. And that really is what methods are. They allow us to do they allow us to carry out some operations on objects or on other types. So that's what we're doing here. I just want to let you know that this is not magic. We have a class called the math class, and we have a method in that math class called the square root, which helps us check. Now let us go ahead and use our own methods that we created here. I'm going to take this away for a bit. So now we want to check. So I'm going to say bool is r1 square equals bool is r1 square equals is shape square. Now I want to use my method, and then I'm going to pass in r1, and then I'm going to say bool is r2 square. I'm going to say is r2 square r2. So what I'm doing here is I'm checking, let's say this is is shape square r2. So I have this first variable to check if r1 is square, and I have the second variable to check if r2 is square. And then I'm just going to write both of them. Console write line is r1 square, console write line is r2 square. Great, so let's run this. So let's see what we're doing here. I created a method to check if a rectangle is a square or not. And then how am I checking if it's a square? I'm checking if the width and the height are the same. Then yes, it's a square. And just look at this. You can answer before we run the code. You probably should get your answer already. I'm just going to clear my console and go .NET run. And so for the first one I have true, and the second one I have false. Let's see if we're correct. So for the first one, yes, height and width are the same. So yes, let's see. So yes, the first one is true. The second one, height and width are different, so we expected false. Because I'm enjoying this, let us go ahead and create another method. And this method will check if we have two shapes in the same position. And this is the kind of method you would want to write if you want to check if a bullet has hit a person, because then the bullet would be in the same position with the person. Now, let's go ahead and do this. So we have static bool, because we want to check if they are in the same position, so we're going to return a true or false to is in same position. And this time, because we're checking two rectangles, we're actually checking if two rectangles are in the same position, so we have to accept two rectangles. So I'm going to say rectangle R1 and rectangle R2. So I'm taking into rectangle and I need to confirm if they're in the same position. So the way to do that is I'm going to say, there are a lot of ways to do that, but I'm just going to really keep this simple and I'm going to check if they're on the same point exactly. So I'm going to say if R1 dot x position equals R2 dot x position. So first of all, I'm checking if the x positions are the same, then so I'm extending my check now. R1 dot y position equals R2 dot y position. Now I'm checking that the y positions are the same. So if this is true, then I know they're the same position. I'm going to return true. Else I'm going to return false. So this simply checks if they're in the same position, and I can come here and say bool is in same position equals, now using my method is in same position. I can pass in both my rectangles now, R1 and R2. So here we see an example of a method that can take two so we call this arguments. I can take two arguments, so we're passing both R1 and R2 to it, and we're trying to find out if they're in the same position. And let's just print that value. Console the right line is in the same position. I'm going to comment this out so we can run the other code. And then now clear, and then .NET run. And there we have it, false. They're not in the same position, right? The reason they're not in the same position is because their x and y coordinates differ. Well, really, right, what I said is programs are composed of objects, and I see one way to make this easier. Instead of having an R1.x position and an R2.y position, let's take this a little bit deeper. Let us create an object or a new class. Let's create a class and call this class position. Sorry, remember it has to end with a .cs, position.cs, and then I'm going to say, as usual, my namespace, class is an object, and then I'm going to say public class position. Right, so I've created a position class. I know every position has an x and y value, so I'm going to say public double x get set, and then public double y get set. So I have a position class. Now instead of having, let's come to my rectangle. Instead of having these two properties on my rectangle of a y position and an x position, and really if we decide that, oh, it's important to know their altitude, we'll have to go public double altitude get set. And if tomorrow we decide that, oh, to know the accuracy of the x and y position is important, we have to come here and add another public double accuracy get set, which starts to become a bit bloating. The way to write programs is to look at your common properties and think, which of these properties can I put together into the same object, right? And we can, instead of all of this, we can come here and say public position get set. So just as we're using our string as a variable here and we're using a double, we can use our position class that we created as a variable too. And instead of having x and y and altitude and accuracy, we can simply take all of this. I'll take this and move it into my position class. And I'll just close this. And suddenly our class is more structured. So I just have a height, width, color, and position variable. Now how do we do this? If we come here, I expect that we're going to have some errors here, because now if we try to run this code, let's go to run, we should have some issues. So we have a lot of issues now, as expected, because I1 no longer has an X position and a Y position, right? And neither does R2. So I'm going to take this here, see, we now have the red lines. I'm going to take this out. Let's give this a color. It's not fair for the first one to have a color. So R2.color equals, oh, we had a color. I remember assigning black to it. Now we have red lines all over here too. So how do we assign this position now, because we've changed the way we're creating the position? So what we're going to do is we're going to say r1.position equals new position. And then we can say r1.position.x r1.position.x equals 100 and r1.position.y equals 100. Let's make it 0, 0. So we have this, and then same for here. We can come and say r2.position equals new position. If you don't create the position, because remember this is a class, we need to create the position object, and then we can now come say r2.position.x equals 5 and r2.position.y equals 10. And suddenly we have to change our logic here. It's in same position. All we have to do now is say, I think we just have to prefix this with position. Position equals x. We just make certain adjustments to this one. I'll just cut this and bring it here instead. Cut this and make it here instead. So suddenly our code works again. But what's different now is that we've created a class for our position, and we have a dedicated class for position. And if we decide, oh, we need more values in here, we can always put them in here. And then the rectangle has a height, a width, a color, and a position. Now, double is actually a class too in .NET. So this is not magic, right? We're simply doing what Microsoft engineers have done to here. So they have a string which has certain properties. For example, we can come here and say, let's create a string my name equals Vincent1. So string, this is my string is a variable, and I can now say my name dot, and when I say my name dot, I see all the methods that are available to me. These are all the methods that are available to me on the string type, on the string class. All of these are defined in the string class. And let us go look at the string class. And this is the string class. It's a lot to look at. Well, let's just go down. And you see it has a lot of methods. For example, it has ends with, which takes a string value, and it just returns what the strings end with. And we have an equals, which checks if two strings are equal. We have a lot of values here. We have an index of, which checks the position of a particular character in a string. And at the end of this day, it's the same thing we're doing here. we're creating a class and we're adding methods to that class. So that really is where we would stop for today. We can run this code again. So I'll first of all clear this and I'll go .NET run, and it's false, of course, because it still works. Our check still works and we have false. And those really are the basics of classes and types, classes and objects, right? So I hope you're following up. This video is getting long. It's over almost 50 minutes or more. So I'm just going to stop it here now. And remember to get back to me if you have any questions or needs for clarification. Thank you.